Alright, hello guys. Welcome to some exam review for Year 8. Today we're going to be going over number and calculation, the exam review we did together in class. Let's go ahead and stop wasting time. Let's get started. So the first few questions, we had working out addition and subtraction with negative numbers. So we had first negative 5 plus 8. When we have different signs, we'll go ahead, we can actually subtract these, and whichever number has the bigger sign is going to be the sign of our answer. So here 8 is positive, it's bigger, so our answer is going to be a positive number. 8 minus 5 is 3, so our answer is 3. Here we have 16 minus negative 4. So we could use the same logic. 16 is bigger, 16 minus 4 is 12. We can also see that we have minus negative. We have two negatives touching each other. This turns into a plus, so here actually it doesn't even work. So we have 16 minus negative 4. This is going to give us 20. Okay, so next we have a set of numbers. We have negative 9, negative 3, 3, and 9. We need to pick two of these numbers to put in the box to make this true. Something minus something else gives us positive 12. There are actually two correct solutions to this. So one, we could take 3 minus negative 9, which minus negative, that's going to give us plus. 3 plus 9 is going to give us 12. So that's one solution. The other solution to this is going to be basically the same, but with different numbers. So we take 9 minus negative 3, and right, so minus negative 3 would be like 9 plus 3, which also gives us 12. So those will be our two different possible answers here. Although it didn't say you have to give both, so just one of those will be fine. Okay, so next we have some multiplication with negative numbers. Negative times a positive is going to give us a negative answer. So then we just look at 4 times 9, which is 36. So our answer is going to be negative 36. Here, let's go ahead and work out, we'll do this one first if we want. So negative 2 times 4, negative times positive is going to be negative. 2 times 4 is 8, so we have negative 8. Negative 8 times negative 9. We have a negative times negative, the signs are the same. Our answer is positive, so we're going to have something positive. 8 times 9 is 72. So our answer is just 72. Okay, moving on, we need to put some numbers in order, some decimals. So the way that we look at this is we look at first our whole number. We have 3's for all of our whole numbers, so we can't say anything from there. Then we're going to look at the first number after the decimal and compare. So we have 2, 2, those are the same. We have 7, 7. Okay, so these two will come before these two. And here we have a 0. So this is going to be our first number. This would come first. So then we're going to go back to these 2's and look at what comes next. Nothing's here, so we can say that's like a 0. And we have a 7. 7 smaller than 0, so this is going to come next. Then this is going to come third. And again, we're going to do the same over here. We have a 2 after the 7 and a 0 after the 7. So this is going to come fourth, and this is going to come fifth. All right. So now, moving on, we've got some BIDMAS to work out. Let's go and write this over off to the side. So we have 3 plus 10 times 2 cubed. According to BIDMAS, there are the B, there's no brackets. I, we have indices, right? The exponents. So we'll solve that first. So 2 cubed is going to give us 2 times 2 times 2, which is 8. Next, we have the D and the M. So division, multiplication, we have some multiplication here. So 10 times 8 is going to give us 80. And finally, we have 3 plus 80, which gives us 83. So our answer to this first one is 83. Next, we have 5. Let's use a different color. So we have 5 plus 2 times 9 divided by 3. So BIDMAS. We have multiplication and division. Remember, we can do whichever of these we want first. We don't have to do division first. We don't have to do multiplication first. We can go left to right. We can do whatever is easiest. I'm going to say that here actually 9 divided by 3 is going to be easier. This is just going to give us 3. So we have 5 plus 2 times 3. And we have multiplication and addition. We do have to do multiplication first. So 2 times 3 is going to give us 6, and 5 plus 6 is going to give us 11. So our answer here is 11. Okay, let's go ahead and scroll down. Here we need to write in brackets to make each statement correct. So again, keeping BIDMAS in mind, we have 2 plus 7 times 3 plus 4 equals 51. If you did this all out, you would do the multiplication here first. 21 plus 2 is 23, 27. So that clearly does not work. However, if we put brackets here, we take 3 plus 4, which is 7. We do that first, and then 7 times 7 is 49. Plus 2 will give us 51. So this will be a solution. And what about this one down here? 4 times 3 plus 2. That would normally give us 14 with no brackets, but if I put these brackets in here, 3 plus 2 is 5. 4 times 5 gives us 20, so that does work. All right. Next, we need to remember what are prime numbers. Write down all the prime numbers between 20 and 30. Prime numbers, remember, are numbers that have two factors. You can only divide by 1 and itself. So if I write down all these numbers, I'll even include 20 and 30, even though I don't have to. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so I need to go and see which ones I can divide by something else that's not 1 or itself. So 20, first of all the even numbers, I know I cannot. So goodbye 20, I can divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. 21, I can divide by 3. 27, I can also divide by 3. 25, I can divide by 5. 23, I can't divide anything by 23, so that's prime. And I also can't divide anything by 29, so that's prime. So my two prime numbers are going to be 23 and 29. Okay, I'm going to go ahead and erase this so we have some room to work out over here. First, we're going to write 72 as a product of its prime factors. So to do this, we're going to start with a factor tree. So let's write 72 up here. We need to think, what times what makes 72? You can take a lot of things. You could take 6 times 12. You could take 8 times 9. I'm going to take 8 times 9 just because, I don't know, I like it. 8 and 9. And then break these down, because 8 is not prime, 9 is not prime. So we need to work this down until we get prime numbers. So 2 is prime, so here we're done. But 4 is not prime. Take 2 times 2. Now it's done. And so we go over to this side. We have 3 times 3. 3 is a prime number. So now we have all of our prime factors. 2 times 2 times 2 times 3 times 3. We want to write it as a product, so in other words, a multiplication problem. So 72 is going to be equal to 2 times 2 times 2. We can write this as 2 cubed times 3 times 3. We can write this as 3 squared. You could also write this just as 2 times 2 times 2 times 3 times 3. That is also correct. This is just a shorter way to write this. Now let's go ahead and talk about HCF and LCM. To find the HCF of 60 and 114, we're going to go ahead and take the prime factors. We're going to do the same thing. So here I'll take 6 and 10. This is 2 and 3, 2 and 5. 114. This is going to be 2 and let's say 57, right? And 57, this is going to be 3 times 19. Okay, so here, to find the highest common factor, what I'm going to do is I need to look at which numbers are the same number of times in both of my factor trees. So I see I've got a 2 here and a 2 here. I'm going to write that down here. I've got a 3 and a 3. Okay, but here I have 1, 2. I don't have another 2, and I don't have a 5. And likewise here, I don't have a 19 over here. So we're just going to take these two numbers and we're going to multiply them. So 2 times 3 gives me 6. And that's going to be how I find my highest common factor. So I take which factors are common to both of my factor trees, the same number of times, and then I multiply them. So that's how I get my HCF. Now let's go ahead and work out the LCM. So again, for the LCM, I'm going to take the same steps. So I'm going to make a factor tree that went 70 and 56. So I'll take the factor tree of 70. So say 7 times 10. Oops. getting too excited drawing my tree before I draw the number. I have 2 and 5. And for 56, I like 7, I'll take that out. So 7 times 8, this will be 2 times 4, and that is 2 times 2. Okay, so for the LCM, it's going to be a bit different. What I'm going to do is, for every time I see a number, a prime factor here, I'm going to have to include it. Doesn't matter if it's in one tree, both trees, I have to include it. The only tricky thing is when I have the same number in both trees a different number amount of times. So let's go and start with 2. I see that I have 2 in both trees, so I'm going to bring it down here. Let's actually use a different color. So I've got 2 in both trees, but here I only have it 1 time. However, here I have it 1, 2, 3 times. I'm going to use whichever one I have more, okay? I'm not going to add them together. I'm not going to subtract them or anything. I'm just going to count which side has more, and I'm going to use that amount. So here, since I have 3 of them, I'm going to use 3 of them here. Okay, so I've used my 2s. Okay, next I've got a 5 here. I don't have a 5 here, but that doesn't matter. Since I have a 5, I need to use it. And finally, I have a 1 7 here and 1 7 here. It's the same. So I'll also take 7. So when I work this out, 2 cubed is going to give me 8 times 5 times 7. This would be like 40 times 7, which is going to give me 280. So the lowest common multiple of these is 280. Okay, so that was a big first page, but we did it. Let's go ahead and move on to the next. All right, so we have some fractions here. We have addition with fractions. We have basically everything except for subtraction with fractions. The first one, we're going to need to find common denominators. I have 1/5 plus 3/4. The way I can find common denominators really quickly, I can take the denominator of one fraction and multiply both parts of the other. So I can take 4 times 1, this is going to give me 4. 4 times 5 is going to give me 20. So that's going to be equivalent. And I can do the same over here. So 5 times 3 is 15. And 5 times 4 again is 20. So here I've got equivalent fractions. Now I just need to add the numerators, the number on top. So I have 19 over 20. I can't simplify. So that's my final answer, 19/20. Here, I could do the same thing, but if I notice 4 and 12, I can relate them if I multiply it by 3, right? So I can just find an equivalent fraction like this. So I know that 3/4 is going to be the same as 9/12. So I can just take 9/12 instead of 3/4 plus 1/12, which will give me 9 plus 1 is 10. But I need to simplify. I can divide these both by 2 now, right? This is going to be the same as, if I divide by 2, 5. If I divide here by 2, 6. So this is going to be 5/6. Okay, we need to work out 3/5 divided by 3/8. Remember, if I have division, this is going to be the same as if I multiply, but I take the second fraction and turn it upside down. I take something called the reciprocal. So I will take 3/5, but instead of divided by 3/8, I'm going to take times, and I'm going to flip it upside down. Times 8 over 3. If I multiply this out, I'll get 24 over 15. However, you might be able to see that if I have something I can divide both by, I can cancel. This will give me 1 here and 1 here. So this will give me 8 over 5, which as a mixed number in simplest form is going to give me 1 and 3/5. Okay, for this one, I have 2 mixed numbers multiplying. The first step I'm going to do is I'm going to make them improper fractions. So 1 and 3/4 is an improper fraction. 4 times 1 is 4, plus 3 is 7. So that's the same as 7/4. 2 times 1 is 2, plus 1 is 3. So that's going to be like 3 over 2. Here I can't cancel anything, so I'll just take 7 times 3 is 21. 4 times 2 is 8. And I need to now simplify and put it as a mixed number. So if I divide this out, this is going to give me 2 with a remainder of 5, which So that would give me 2 and 5/8 as my final answer. Okay, moving on, we have a list of numbers, 3, 5, 9, 16, 19, 27, 28. From this number, I need to write down what is a factor of 12. So what numbers can I multiply together to make 12? 1, 2, 3, 4, 6, and 12. Okay, well, 3 is the only one of those numbers in this list. I need to write down a multiple of 7. Okay, so 3 is not, 5 is not, 7. Here, 28 is, right? 4 times 7 gives me 28. I need to write down all the prime numbers in the list. So what numbers can I take? What is a prime number? It's a prime number that, it's a number that can only divide by 1 itself. So I have 3, 5, right? 1 and 5. 9 I can divide by 3, so that's not prime. 16 I can divide by 2. 19, that is prime. 27 I can divide by 3. 28 I can divide by 2. So these are my 3 prime numbers. Let's move down the sheet. Okay, we need to write the following fractions in order of size, starting with the smallest fraction. So we can do this 2 ways. We could either find common denominators, or we could think of them as decimals. Here, I'm actually going to suggest the decimal method because it might be just a little bit easier for us, okay? So going through 1/3, if I want to write this as a decimal, I'm hoping that we all remember this is going to be like 0.33333 forever, right? 2/9, again, I'm hoping to remember that these are going to be like 0.1111, 2222, depending on what our numerator is. So 2/9 is going to be equal to 0.222 forever. 1/4. This is going to be, again, I really hope you remember, 0.25. Next we have 3/16, which if you're not sure, you can always just work it out using long division. 3 divided by 16. I'll save you a little bit of that trouble right now. This is going to give us 0.1875. And finally, 3/10 is going to be 0.3. So now it should be much easier to compare these, right? So looking at the tenths, I already see my smallest is going to be this one, so 3/16. Next, I have 2 and 2. The infinite 2's are going to be smaller, so we have 2/9. Then I have 1/4. Finally, I have 0.3. Oops, I should write that as a fraction, right? So 3/10. And finally, 1/3 will be my biggest fraction here. Okay, finally, there's 17 counters in the bag. I've got a table showing how many of each I've got. What fraction of the counters are blue? Well, we just see there are 2 of them out of 17. So we simply need to write 2 out of 17. Hopefully that one is a nice easy point for your exam. Okay, so we've gotten through half of this already. Let's keep going. So what is the difference between 3/8 of 32 and 2/5 of 40? So we need to find fractions of an amount. So to find a fraction of an amount, let's take 3/8 of 32. The way we do that, we're going to take our number. We're first going to divide by the denominator. So 32 divided by 8 is going to give us 4. We then take that and multiply it times the numerator. So this is going to give us 12. For the other one, 2/5 of 40. Again, so we're going to take 40 divided by the divided by the denominator, the number on bottom, 5, which is going to give us, again, 8. But here, we're going to take 8 times the number on top, 2, is going to give us 16. So we have 8 times 2 is 16. So we can see 16 is bigger than 12. So we see that we need to work out the difference. So 16 minus 12 is going to give us 4. So the answer here is 4. Okay, convert 5/6 to a decimal. Some of you may already know what this is. However, if you don't, no worries. We're going to show you how to find it out. Well, really any fraction. But we're going to use this as our example. Let's use a different color. I'm tired of blue. So the way we do this, we're going to take the number on top, so 5. I'm going to add a decimal point and some zeros so that we have some space to work out. And I'm going to divide it by 6. So 5 divided by 6 I can't do, so moving on. 50 divided by 6, I see that can go into it 8 times. 48. Subtract, that gives me 2. 20, I'll see that 6 goes into 20 3 times. 3 times 6 is 18. Get 2. And again, we'll see that I end up here, this kind, in an infinite pattern where I have 3, 3, 3, 3, 3 forever. So I don't need to do any more work. I'll see that this is going to be 0.83. I can put a dot here, I can put a bar, you can put your parentheses as you wish. Your answer should be 0.83 with a 3 somehow repeating. Somehow show that it is repeating. Okay, so we have some more putting things in order. All right, I'm going to go ahead and put these back into decimals again, just because it makes it a bit easier for me. So 1/3 we already remember is going to be 0.3 bar, 33333 for repeating forever. This is like 0.21, and this is 0.25. So we can see that this is going to be our smallest, right? If we look at the tenths, we'll see we've got a 2, a 2, a 2. So these will be our 3 smallest. Then we have a 0 afterwards, so that's going to be our smallest. This will be our second smallest. This will be our third smallest. Finally, this will be our fourth, and this will be our largest. Okay, we need to write 9/20 as a percentage. So the way that we can do that, I'm going to first convert it into and I can convert this into a decimal, or I can convert this into an equivalent fraction over 100. I see here that this is going to be easy to convert into something over 100. Why do we need to convert it into something over 100? Well, percentage means something out of 100. So we'll take 20 times what? Will give us 100 times 5, so we're going to do that to the top as well. So 9 times 5 gives us 45, so we have 45 out of 100, and whatever we have out of 100 is going to be that as our percentage. So we have 45%. Next we have some rounding. 2,437 to the nearest hundred, so we're going to look at the hundreds place and the number after it to see if we need to round up or round down. So since the number after it is a 3, it's less than 5, so we're going to leave this number the same and fill the rest in with zeros. Next we need to write 5.4096 correct to 3 decimal places, so we're going to have 3 numbers here. So I already know that 5.4 is going to be correct. So we're going to have it up to here, so I need to look at the number after this. See if it is 5 or greater, I'm going to round up, and if not, I round down. Here, it's 5 or greater, right? It's 6, so that means I'm going to round up. I do have to be careful here, though, right? Because I've got a 9. When I round that up, it's going to give me 10. So I'm going to fill this in. It's actually going to bump this up to maybe even the next decimal place, right? I don't need to write the 0. I can if I want. It's not wrong. I can write either of these. And finally, write 2.79 correct to 1 decimal place, so I only want 1 number after the decimal in my answer. So I'm going to look at the second decimal place. Again, 5 or bigger, it's 9, so I'm going to take the 7 and round it up to an 8, so I have 2.8. Okay, work out 10 to the 4th power. If you have 10 to any kind of power, this is essentially just going to tell you how many zeros you have. Right, so I'd have 1, 2, 3, 4, 10,000, and we're done. I could also think of this as 10 times 10 times 10 times 10, which again will give you the exact same answer. Here we need to work out the value of 5 times 10 to the 3rd. This is going to be like 5 times 1, 0, 0, 0, 3 zeros. And so this is going to give me 5,000. Here we need to write down the value of the square root of 81. What number times itself is 81? Hopefully by now we know this number is 9, right? 9 times 9 gives us 81. And we want to work out the cube root of 64. This one might be a little more difficult. What number times itself gives us 64? We'll work out 1 times 1 times 1 is 1. 2 times 2 times 2 is 2. Is 8. We can work this out. We'll eventually see that it is 4. So 4 times 4 times 4 gives us 64. Okay, so we'll move down a little bit, almost done with this 3rd page. Here we've got a list of numbers. We need to write down all the square numbers. So as a refresher, square numbers are when I take the answer is when I get to take 1 squared, 2 squared, 3 squared, 4 squared, and so on, right? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared would be 25, 6 squared would be 36, and so on. These are all my square numbers. So looking at this list, what numbers do I have? So I don't have 1, I don't have 4 or 9. Oh, I do have 9, so there's 9. I've got 16, I've got 25, I don't have 36, and the next would be 49. So my 3 square numbers would be 9, 16, and 25. Okay, last one on this page, almost done. Molly, Paige, and Demi share 42 sweets in the ratio 3 to 2 to 1. You need to work out how many sweets each of them receives. So the way that we do that, the way that we share in a ratio, we're going to take our ratio. First, we're going to add up all the numbers together. 3 plus 2 plus 1, this is going to give us 6. Then we're going to take the amount and we're going to divide it. We're going to figure out how much one share is by dividing it by this answer. So 42 divided by 6 is going to give us 7. So now we're going to be taking this number and multiplying it by each one of these. So Molly is 3 here, right? We're going to take 3 times this answer, which is going to give us 21. So Molly gets 21. Paige, right, she had 2, right? We're going in order, so we're going to take 2 times 7. So Paige gets 14, and Demi gets 1 share, poor thing. So we take 1 times 7, which is just 7. And there we have it. So Molly gets 21, Paige gets 14, and Demi gets 7. And if you add them all up, you do get 42. You can do that as a way to check your work. Let's go ahead now and move on to the last page of this review. Okay, so we got some more ratios here. Dave is making cookies. He mixes flour, butter, and sugar in the ratio 6 to 4 to 1. Dave uses 160 grams of butter, so we need to work out how much flour and sugar Dave uses. So we need to first of all figure out which one is the butter. So flour, butter, sugar, that's going to be here in the middle. So we need to figure out what 1 share is. So if he's using 160 grams in total, and that represents 4 shares, take 160 divided by 4, this is going to give us 40 grams. Grams here, so don't forget, for 1 share. So 1 share is 40 grams. So we already know the sugar, since it's just 1, is going to be 40 grams. But the flour, he uses 6 shares. So we're going to take this amount times 6, which is going to give us 240 grams. So for flour, we have 240 grams. All right, moving on to the next recipe. Fred has a recipe for 30 biscuits, and here's the recipe. 230 grams of flour, 150 grams of bacon, 100 grams of caster sugar, and 2 eggs. He wants to make 45 biscuits. So what we can do, we can see that 45 is going to be basically like 30 times 1.5, right? So we can either take everything here times 1.5, so 30 times 1.5 equals 45, right? Or another way to do this, we can take half of everything we see here and then add it back to the original amount, which is what I'm going to do because I don't really like multiplying by decimals by hand. And figuring out half of things is much easier to do in my head. So taking half of 230, I'll work this out by hand just to show you for the first one. 230 divided by 2, it's going to give me 115. Then adding that back to the original is going to give me 345. So for 45 biscuits, he needs 345 grams of self-rising flour. Half of 150 is 75, which is going to give me 225. So he needs 225 grams of butter. Half of 100 is 50. So 100 plus 50 is 150. He needs 150 grams of sugar. And eggs, half of this is 1. 2 plus 1 is going to give me 3. So he needs 3 eggs. So these would be the amounts he needs for 45 biscuits. Next, there are 500 sheets in a pack of paper. 500 sheets of paper weigh 2.5 kilograms, so we want to work out the weight of 50 sheets of paper. So let's see what fraction or what percentage this is of 500. So the total here, if we take 500, divide by 50, this is going to give us 10. So we're simply going to take this and divide it by 10 as well. So we take 2.5 divided by 10, which is going to give us 0.25. So you could say this is 0.25 kilograms. Don't forget your units. Or if you wanted, you could say this is 250 grams. Okay, let's go ahead and scroll down. We're almost done. It costs 75 pence to buy 5 bananas, so we want to figure out how much it would cost to buy 7 bananas. So we're going to figure out how much we pay for 1 banana. So 0.75 divided by 5. This is going to give us what? 15, right? 0.15 rather. Okay, and now to find 7 bananas, we need to just simply take this answer, 0.15 times 7, which is going to give us 1.05. So our answer would be 1 pound and 5 pence as our final answer. Okay, find 45% of 820. If you like multiplying decimals, or if you have a calculator, a very quick way to do this will be to simply convert 45% into a decimal. Let's use a different color here, 0.45, and multiply it. You can multiply this, and this will give you your answer. There are no further steps. However, if you want to do this in your head, there are a few things that we can do. So we could say that, okay, this is close to 50%, right? So to find 50% of 820, I just take half of it, right? I divide it by 2. 8 divided by 2 is 4, 20 divided by 2 is 10. So I'm going to see this is 410. What was the difference between this and 45%? Well, it's 5%, right? Well, if I already know that 50% is this is just going to be 10 times less, right? So if I take this and just divide by 10, I know that 5% is going to be 41. And if I subtract 50% minus 5%, this is going to be 45%. I could just take 410 minus 41. So this is going to give me 369. So 45% of 820 is 369. Let me go ahead, since I am paranoid, let me double check that with my calculator, since I'm doing this all at the top of my head. 820, and I do in fact get 369. Okay, last problem here. We need to figure out which is greater, 30% of 105 or 32% of 98. We need to show our working. Okay, so to find 30% of something, we can take 105. We can either divide by 10 and then multiply by 3, right? So we get 10.5 times 3, which would give us 31.5. Or you could just simply take it and multiply times 0.3. We'll do the same thing for this one. Since this is almost 30%, we will take 30%. So we'll divide by 10. That gives us 9.8. 9.8 times 3. That is going to give us 27 plus 2.4, which is 29.4. Now we just need to find 2%. So we know that 1% would be basically taking this and dividing it by 100. So it would be like 0.98 would be 1%. So 2% would just be doubling that. So that would be this times 2 or plus itself. So it would give us 1.96. So when we add 1.96 here, this would give us our 32%. So we get 6, 3, 1. So we get 31.36. So 31.36 is just slightly smaller than this. So we can see that 30% of 105 is greater. which brings us to the end of our practice exam. So if you have any other questions, please let me know. I hope this video was helpful, and I will see you all in class.